Hi, hope you're all doing good. This is Graviflyer Thoughts and Observations video number 6. It's a follow-up to video number 5 where I promised a schematic to the high voltage power supply, in particular the pulse generation to drive our IRF 540 here. There's lots of different ways you could do this. This is a little weird, a little different. Okay, so what are we talking about here? We're talking about the utilization of analog modular synthesizer circuits in order to help us generate high voltages, AC, DC, AC signals for the ultrasound to drive the PZO, and even pulse trains to drive stepper motors. My eventual goal is to replace the motors with steppers so that I can control the speed of the rotation as well, and the syncing and timing of it. Okay, so this is based on a old school sawtooth core oscillator, late 60s, late 60s, early 70s. I'll do a shout out to a bunch of people who contributed to the design of early analog music synthesis, in particular VCOs, which are pretty tough to get them to track and just be stable in general. Of course, it's all temperature issues generally. Okay, so let's just get into it here. Really, they should be calling these current controlled oscillators, because in fact it always utilizes some sort of current source or sink here. You've got a capacitor in the negative feedback loop of this op amp, right? So we've got an integrator here, and so it's drawing current out of the capacitor, and then with the inversion we're getting a positive going sawtooth on the other side. Okay, the threshold, the top of the sawtooth, is set with this 20K, 10K, right, voltage divider here. All right, I'm using a bipolar 15 volt supply, so that gives me a 5 volt threshold here. All right, so that fires this comparator and makes our FET here, our 3819, go ahead and close down and discharge our cap, right? So it brings us back to 0. All right, in order to get everybody cohesive, you've got some scaling happening here with your voltage input. We're gonna go for the 1 volt per octave musical standard, right? Which, what we're trying to do is scale this down to 18 millivolts here to allow us to get a doubling of current through this transistor here, right? So it goes like this. Okay, so of course that's all set with this resistor here. The advantage of using the analog modular synth realm is that you get all sorts of control and extra features that we don't normally get with high voltage production, such as voltage controllable frequency, linear FM. You get pulse width modulation. We'll get into that a little bit. And then you get your sync input, which is what I'm most interested in, is syncing up the various timing functions or timing generators, pulse generators, the ultrasound, get them all on the same page and at least start with everyone in sync, and then slowly take things in and out of phase and see what the results are. We've already seen that the ultrasound and the center disc that's associated with the Tesla coil, they definitely interact with each other. So I'm looking to, kind of follow that lead and see if I can get more repeatable interactions, right? So that we're kind of figure out where we're going here. What are we looking at? All right, so in general, yeah, so integration here, compare here, right? Threshold set here. Unfortunately, this does use a bipolar power supply. There's lots of other oscillator designs. I'm working on a single transistor design to hopefully replace this that utilizes unipolar power, right? So we can go battery. Otherwise, you can't do 2 batteries and get a bipolar power supply going if you need to. Also, if you don't want to go with all of this scaling and volt per octave response. You can go with a simpler setup here, so you can just, you know, eliminate all of this and go with this. It's the same situation, looks a bit odd, but it does work. Make sure that's negative, right? And then yeah, watch your polarity over here. It is a little particular. Okay, and then you've got some pulse width modulation. So you've got an initial pulse width mod and a CV over your pulse width modulation as well. This is super handy, especially with the DC generation, and we'll look more at that. I got another video coming to show you something interesting there. Here's our IRF 540. Definitely want some opto isolation or an isolation transformer in here, perhaps just to, you know, separate yourself from you know, the activity to all your sensitive devices. The op amp is a sturdy device. It's proven to be really, really hardy. It's way more solid than a 555, I'll tell you that much. All right, we got a cap here, right? So 4001 across our primary, just to take care of those voltage spikes, right? That's 100K there. I'm using 6 turns on my primary. Again, this is just a raw, you know, there's plenty of interpretation and places you can go with this and improvements you can make. But, you know, I'm bringing it into the analog modular synthesizer zone because you've got control over timing, control over, you know, your frequency, your syncing, your all sorts of things, pulse width, all in real time. So you can adjust these things and start looking for patterns and responses. And you know, instead of just having 3 or 4 devices that aren't really related to each other, but they're all doing something within the system, and you're kind of all waiting for them to come into cohesion. You know, at least with this setup, you can have a starting point. All right, so all this is, you know, all ripped off from old school modular synth stuff, and so a bit of the tip of the hat for some of these hardworking people who brought us all these wonderful technology. One of them was Bertie Hutchins. He started this, see that, Electronotes, probably in the late 60s, early 70s. Anybody who was anybody apparently had a subscription to this newsletter. And yes, it would get copied and sent to you in the mail, and you'd send them a check. It's very old school. But you know, Dave Rossum, Don Buchla, Serge, just about anybody was on this mailing list. Tom Overheim, another excellent book on modular analog synthesizers, and actually just great in general is Al Chamberlain's Musical Applications of Microprocessors. This is a wonderful book. It's very old school, but it covers all sorts of things, and you can get into the early days all the way into computer controlled and digital generated synthesis. This is all for audio, but is very applicable to what we're doing. And here's a lot of what you're looking at right here. Another great book in electronic music circuits from Barry Klein. This one's pretty particular, and as you can see, it's like I've looked at this so many times it started to come apart on me. But again, analog modular synthesizers are basically analog computers, you know, that produce sound. So utilizing an analog computer to actually give us some control over the high voltage generation of the Graviflyer, I think will help considerably. All right, and another great book, Walter Jung, IC Amp Cookbook. And really good. Can you see his name there? You gotta go check out Thomas Henry. This guy's been doing it a long time. Excellent author, and just really down-to-earth explanations. Just laid out for you. Thomas Henry. All right, this video is way too long. thanks for watching, and I'll have some more for you soon. Take care.